today. All right, so 10.2. Tomorrow's going to be 10.3. Okay, or we'll see what happens at the end of the day, but I most likely tomorrow we're going to aim for 10.3 and the 9 and 10 review since it's Thursday. So, yes. All right, so today we're going to be looking at 10.2 time value of money. So we've learned in chapter 9 what happens when we're dealing with cash. And then in chapter 10.1 what happens when we deal with customers who owe us on an account. Now we're actually going to look at time value of money. So what time value of money actually is that we have to assume that our current currency, which is the dollar bill, is that it does not hold its value over time. We all know this. We all know this from our, the government, and also just looking at how far a dollar was back then to how much it's worth now. There's a lot. You can go on the internet to see how much the dollar is worth, and accordingly, it is to the gold standard. So we all know that. But we definitely know that with time, our dollar has stretched a lot, especially in these times right now, right? We're currently in a really huge depression, recession, a lot of downs right now, and the government right now is pushing a lot of money in circulation, we call it. They're pushing a lot of money in circulation, so that's what's causing the dollar to lose its value, especially right now, because we're in like kind of like a crutch right now in the economic right now. Oh my gosh, I can't talk. So with the assumption of this, we have to assume that when we make projections into the future, we can't assume that the dollar is always going to stay a dollar. Because as we know, even if you look up the value of a dollar, it goes, if you look at the chart that they provide on the internet, I believe it's the Treasury, you will see on a day-to-day basis of how much your dollar has changed over time. Now, of course, there's lots of reasons why we have inflation it's inflation and things like that, because over the past years, right, there's always something going on, whether it's in the government, and the true meaning of inflation is basically how much more money you're pushing into circulation. So the more money that is in circulation, obviously, the less value it is for a dollar. So like right now, right, back then, 99 cents was for gas. Right now, it's probably close to anywhere from $3 to $4. So, imagine how far it was back then. Like a dollar back then was hard to earn. It was hard to make, but everything was so cheap. Now everything is anywhere. Nothing that you can buy is for less than $1, except for the dollar store. But things like that, you can always assume, you're always going to have to make the assumption that with the dollar, it will lose its value over time. So again, a dollar 20 years ago is definitely not the same as a dollar today, right? It's probably equivalent to like $5 today. Okay. So with that being said, this is what time value of money does. Time value of money it's basically a calculation that you do. So you calculate the assumption that inflation or whatever it is that you're calculating, that today's value of a dollar isn't going to be the same as in the future. So with that kind of projection, right, this is more geared towards when we decide to make bank loans, or when we decide to receive, so bank loans is one, and if, credit cards is also a good example as well. But also like things or like bank securities or bank bonds, right? You have to invest originally, right? And of course, they give you a time, an interest rate, and how much you're going to accrue. But and the time limit too. And you can assume if you put in $1 into the bank today and you expect it to accrue, obviously, 20 years later, if you pull that money out, it should have increased its value. Okay, but here's the downfall for this. Like we've mentioned before, $1 today, 20 years fast forward, it's not going to be the same. It's going to lose its value very significantly. So your $1 that you invest is not going to hold its value in 20 years from now. It's probably going to be worth like 20 cents at that point, right? It's going to take $5 to equal up that $1 that you have in your bank. So that's what I mean by this. And this is a calculation that all banks use, because again, we have to assume that inflation is a real thing. Okay? We have to assume that our dollar will not hold its value as it will today. Okay? So that's why we have two types of interest that we're going to be calculating: simple interest and compound interest. So again, for this specific class or scenario, we're only primarily looking at either bond securities, or we're looking at a bank loan. Okay? The two types that so you have a positive interest and you have a negative interest, or in this case, interest that allows you to increase your assets, and you also have one that increases your liabilities, right? You owe more money than you originally signed up for. So of course, there are two different types of interest that you can see. So the first one is going to be called simple interest. Simple interest is most commonly used for bank securities or bank bonds, okay? Usually what happens is you are assuming that you're getting a lump sum money and you're calculating the interest one time only, and whenever the given year that you can claim your money back is is basically it. You're only calculating it once. That's simple interest, all right? Key components that are entailed are going to be your principal, which is your original investment, your interest rate, okay? So it'll be a percentage. You also need to know a percentage will always be an annual rate unless it's specified that it's every month, okay? But usually interest rates are most likely going to be considered or understood as an annual rate. And then lastly, you have the last component, which is time. All right, so usually it's measured in years, but if it is measured in years or less than a year, then you're going to have to do some kind of conversion to be able to understand how to do the formula, right? So every time we're doing this, we're assuming that the formula for the simple interest and even compound interest as well is going to be based on the year, okay? And then we're going to talk about compound interest. So compound interest is what we widely normally see every day. We see it in credit cards, in bank loans, student loans, any type of loans that you can think of is the most common one that we use for compound interest, because first thing that we got to do is you're constantly compounding it, meaning you're going to be charged interest, right? Credit cards, you're charged interest every month. So in this case, you're compounded monthly, okay? Most bank loans, right, if you are, choosing to select the one that accrues every day, you're looking at 365 day interest. So daily interest, you're going to be calculated over and over again. That's more common for when you actually get a car loan. It accrues every day. All right. So you want to. So the cool thing about understanding how to calculate this interest is if you do go out in the future, your benefit isn't when you go out to get a business loan, you can calculate this yourself, and you can also calculate what is the best percentage for me. But another thing is you could also calculate, okay, well, if I make my monthly payments, if I go above the payments or if I make multiple payments, how much quicker can I pay off my loan? So that's a huge advantage if you understanding how to utilize time value money. You can set aside and think about, is this bank loan worth it? Is it is it a high interest rate? And if I obviously pay quicker, how much payments do I need to make in order to pay it off quicker? So this is the great thing about that one too. And like I said, it's the most common one that you would normally see. All right. Same variables, except one thing is added in there. It's because again, you have the principal, which is your original investment. You have your interest rate, which is again in that annual is normally in terms of an annual rate, meaning it's for the whole year. The extra component here is the number of times you are being compounded. So the number of times you're being hit with interest, or in this case, where interest keeps calculating. All right, the number of times. So how many times are you being calculated with interest? And then lastly, time, right, which is usually measured in years. Okay. All right. So with that being said, let's go ahead and move on to the first one. Here is the formula for simple interest. Pretty straightforward, right? A student of mine created a mnemonic device. You think of simple interest as pretty, right? PRTI, pretty. So it's going to be obviously your principal times your rate times your time to equal the interest. All right. And to solve for the future value from there is going to be your principal plus your interest. All right. So again, down below is your actual equation here. So I equals PRT. So you're just multiplying right across. Pretty straightforward, pretty simple. Unless R is given in terms of not an annual rate. And T, if it's not given in years, you're going to have to figure out another calculation there. But the components is pretty straightforward. It's principal times rate times time to get your interest. And your future value, that's what FV stands for, is going to be what you're going to determine that your principal, which is your original investment, plus the interest that you've accrued, what is your total amount that you're going to be looking forward in the future. Okay? So let's go ahead and do a little simple example here. So here, you bought a bank bond from the bank that's worth $100,000, right? And the interest rate is going to be 6%, and you can redeem it in 5 years. So as we know, right, bank bonds, you can't just redeem it whenever you want. And usually there's a time frame of when you can redeem it, right? Usually the whatever you agree on, you can extend it obviously, but when it's redeemable, available for you to claim, you can claim it within that year, or you can extend it for another whatever, right? So that's the assumption here. I am going to redeem it in 5 years. So my principal is what?
100,000.
Okay, and my rate?
6%,
6%, and my time?
5 years.
5 years. Now, every time we're given a rate, right? When we multiply it, right? We have to convert it in terms of decimal points. So in this case, the rate is going to be 6%, which is also equivalent to 0.06. Right? We've been dealing with tax, so you guys are very familiar with rates. Okay? So I want to solve for the simple interest on this bank bond. So let's go ahead and solve for the interest. So what is going to be, calculate your interest. What's the interest going to be? $6,000. No, it's not. Try it again. $100,000 times 0.06. You forgot the 5.
Times 30,000.
Times 5 to give you 30,000.
Yeah.
So you stopped at P and R.
I stopped. Yeah.
So there's three components. So 30,000 is your total interest that you're going to collect. All right. Now let's go ahead and solve for my future value. If I were to claim it in 5 years, how much should it totally? How much in total should it be?
130,000.
130,000. That's correct. So in this kind of sense, right? We're waiting 5 years to collect $30,000. And as much as I have to say it, that's true for all bank bonds, right? They give you the lowest rate, interest rate, and they expect you to wait on it for years. And of course, with that kind of incentive, right? First off, who's gonna have $100,000 readily available? And then you're only getting 6%. So think about it. Is this bank bond really worth it? In most cases, no, it's really not. And what happens is that a lot of people goes to the stock market instead because that's technically a better investment. However, there's a higher risk to that, right? You can lose your money in one day. So that's but you can accrue money in an instant. But that's why this is just an example here for a bank bond. So that's typical of bank bonds, right? They don't give you that much high percentage of interest rates. All right. So here we looked at the bank bond, and then if in 5 years I collect it, it's going to be worth $130,000. Okay. So that's the simple interest. Any questions?
No.
Nope. Pretty straightforward. Pretty easy. Now we're going to be looking at compound interest. Now, you cannot do this on a regular calculator. All right. This actually has to be either done on Excel or if you have a graphic calculator. All right. The ones that has like all those exponents, all those extra scientific numbers on there. You can do it on that, but you absolutely cannot do it on a regular calculator. All right. Now, I'm not going to ask you to go buy one because I'm not going to have you spend $100 because those graphic calculators are expensive right now. They're $100 and for just this one problem in class. So I'm not going to ask you to do it. However, I will teach you how to do it on Excel. So if you do want to know how to do it, I will show you how to do it on Excel. All right. But with this one, now this one's going to be different here. When we're going to be calculating compound interest, so the formula for interest is going to be your future value minus your principal. So that means when I need to solve for compound interest, I have to solve for my future value first. And your future value is going to be your principal times 1 plus your rate divided by the number of times compounded, parentheses, exponented, all right? So you've raised up to the nth times t power. Okay? That's how you read it. But if you look down below, it's FV equals P, parentheses, 1 plus R over N, parentheses. Caret means the exponent. In this case, we're going to use carets in Excel. But it's raised to the n times t power. All right? Now, yes. Okay. All right. So again, you cannot do this on a regular calculator. And how to do it on a graphic calculator is it's actually pretty easy. And I'm going to show you how to do it on Excel as well. So let's go ahead and take this example right here. So it's the same exact example, except you have that it's compounded quarterly. Okay, so you bought a bank bond, $100,000. Interest rate is 6%, but you're compounded quarterly, and you are going to redeem it in 5 years. So, what's my principal? 100,000. What's your rate? 6%. Now, what about number times compounded? That's time. Your time is 5 years.
Would be what, 20 times? It's quarterly.
Okay, so when we understand quarterly,
We have 4 quarters, so it's 4 times.
exactly, there you go, thank you. So exactly how you explained it was exactly what I was going to say. it's saying that you're going to be hit with interest quarterly, every quarter. So that means you're going to be, there's, and you know, as we know, a whole year, right? If you're doing in quarters, it's split into 4. So you're going to be hit with the interest or calculate with the interest 4 times. So that is correct. All right. So now let's go ahead and solve for our future value.
It
Okay.
wouldn't be 4 times every year.
4 times every year. So when you are correct in terms of if you're looking at the end goal, right? You're doing it for 5 years. And that's exactly what the formula says up here. If you look at that exponent, it's n times t. N times t, which is 4 times 5, that gives you to the 20th power. So you are correct in a sense if you're looking at that way.
So really it's more the number of times compounded each year?
Each year, correct.
Okay.
Yes.
That makes more sense. Okay,
Yes.
to phrase it that way.
Okay.
Right, thank you.
Mm-hmm. Okay, so yeah, each year. So we understand that it's compounded quarterly each year. So yes, so that means you get hit with the interest or calculated interest 4 times a year. Okay, so here you go. We plugged it in. Now the question is, we need to be able to solve for our future value. So this is where I'm going to go ahead and show you how to do it in Excel. All right. Obviously, we're going to do it afterwards, but this is what you're going to punch in your cell. You're going to punch in the equal sign, P, the star, parentheses, 1 plus per open parentheses, R divided by N, right? Slash N, parentheses, caret, parentheses, N times T parentheses. Those parentheses are very important that you have in there because if you don't have it, Excel is just going to calculate it as it sees it. It's going to calculate P, right, times 1 plus R, and then it doesn't know what to do with N. It's going to divide the whole thing by N, which is not what we want. We don't want 1 plus R divided by N. We want 1 plus parentheses. We want R to be divided by N. We don't want 1 plus R. So if you don't have that extra parentheses, you're actually essentially going to kind of mess up your formula here. So it's very important that you do have the correct number of parentheses in there. Now, oftentimes what happens is some students, they make a mistake here too because they always forget that second parentheses right there. So they open the first one, then they put one right before the R. They forget to close the double parentheses at the end of the N. All right? So that's very important that you make sure because Excel will not accept it. You'll keep getting errors left and right. All right? So what happens here is you're going to take your future value is going to be the $100,000. You're going to multiply it by 1 plus the rate, which is 0.06 divided by 4. Okay? Parentheses, caret, which is exponent, right? And then it's going to be 4 times 5. Okay. So in this case, of course, I'm going to assume you don't have your Excel with you, so the answer should be 134,685. And of course, in order to solve for interest, interest is equal to future value minus principal. So pretty straightforward. You're going to take your 134,685 minus your original investment, and your total interest is going to be $34,685.50. So looking at the difference between a simple interest and a compound interest, it seems to be that the compound interest actually is a little better. But here's a few things and few rules because it just really depends on what your original investment is. Obviously, if you invest a lower amount, like $20, the difference between the compound interest and simple interest is not by much. Okay? This one is because you're being hit with the interest 4 times, right? Instead of being hit with interest just once. Okay, so that's why you're able to collect an additional $4,000 on top of that. So whether you whether you wait out which one's better, it just depends on what your original investment is, and it also depends on what your rate is. Okay, so that is compound interest. All right. Any questions? No?
No questions.
All right. So let's go ahead and dive right into the chapter 10.2 exercises. Oops. Sorry. All right, so question number 1. All right, I even for the Excel worksheets, I went ahead and placed the formulas right above. So, yes. So here in this question here, it says that you bought a bank bond worth $225,500. Okay, the simple interest rate is going to be 7.45%, and can be redeemed after 3 years. Okay, how much is the interest worth? Okay, how much is the interest? So in this case, I have it readily available in their little tables. So my interest that I can collect here, what's the formula for my interest?
Principal times rate.
Principal times rate times.
Time.
Yes. So in this case, 22550 times 0.0745 times 3. What is my total interest collected here?
5399.25. I'm not sure.
539925. So then, what is my total future value going to be?
Interest plus principal.
Correct. So in 3 years, how much is this bank bond going to be worth?
I have 275.899.
Good. Yes, and then of course, I have to extend this out just a bit. There you go. 0.25. Good. All right. Straightforward. This is pretty easy. All right, so number 2, we're just going to keep practicing these. Now, this is where I was talking about when you have extra numbers that are not in terms of years. So let's go ahead and go for the very first one. Your principal is $15,000. Your rate is 5.12%, and it's in 5 years. So what's my interest going to be here?
3,840.
3,800. Yes. Let me put these in terms of dollars so then they can. All right, good. So then what's my future value going to be?
18,840.
18,840. Okay. Now let's look at scenario number 2. I invested $4,521.50. My interest rate is 2.45%, and it's going to be my time for it is going to be 90 days. Okay, so let's take a look at that. If I'm supposed to have this in terms of years, what is 90 days equivalent to?
3 months.
3 months. Okay, so 90 days, right? You said is equivalent to 3 months. Is equivalent to 3 months. Now, in terms of whatchamacallit, in terms of years, how much is 3 months?
1/4.
3 months, right, is 3 out of 12, which is essentially, you're right, it is going to be a quarter. So in this case, oh, I wrote the date in here. So 3 divided by 12, which is essentially a quarter of the year. Okay, I'm going to format it in this. Okay, so 0.25. So we know that when we're calculating this, we're going to calculate in terms of years. So instead of using 90 days, we know that 90 days is equivalent to 3 months, which is equivalent to a quarter of a year. So when you're calculating the interest now, it's going to be your P times your interest times a quarter of a year, because that's all you are subjected to for time. So what is that going to be? What's the interest going to be if you're only calculating a quarter of a year?
2769.
2769. All right. And then lastly, what is my total future value going to be?
45, 49, 19.
45, 49, 19. So in this case, most bank bonds, okay, the shorter term that you have, you're most likely to get a really low interest rate. Okay. For loans, obviously, you're going to have a low interest rate if you pay within a shorter amount of time. But the longer you have your loan for, the higher the interest rate is, right? Crazy. I don't know why. It's crazy, but that's how the rule goes. That's why a lot of people, they want to try to pay as soon as possible so they could try to get the lowest interest rate. But then again, there's lots of rules and regulations when it comes into the interest rate when you calculate bank loans, because there's actually a little small concept that you don't know. You're actually paying for the interest first, and then you actually pay off your entire principal itself. So you're actually paying, it's already been calculated. They've already calculated the total amount of interest that you're going to be paying for, and they make you pay it first. You're not paying your actual debt that you actually owe, or your original investment. Crazy as it sounds, but that is actually true. So make sure that if you do have a bank loan, you tell them, I want to make a payment towards my actual principal, not the interest. But usually that only happens if you make double payments, obviously. Okay, or more than one payment per whatever cycle you have. All right, so again, now we're dealing with 6 months. How much is 6 months out of a whole entire year?
2/4.
50.50.
It'd be 50%, right? If you're doing 6 months, right? There's a total of 12 months in the year. So in this case, what you can do is it's going to be so for example, right? We know that it's 3 months. You're going to divide it by 12, because that's how many months you have in one year. So that's why we got the 25%. Same thing here. If it's 6 months, you're going to divide it by 12 to get 50. Now, if I give you an odd number of months, right? Let's say I say 5 months, you could still calculate it by just dividing it by 12, and you'll get this long number here. So in this case, you are right. It is 0.5%. I'm sorry. It is 50% of the time. So so you're going to be multiplying your $384,125.22. It's being multiplied by the 7.89% times 0.05, because times 0.5, because it's only for 6 months. It's half the year. So what's my total interest here?
15,153.74.
Good. And lastly, what is my principal going to, what is my future value going to be?
399.78.96.
Okay. Yes. Good. Good. So again, yes. And that's how you do simple interest. Okay. Good job. So question number 3 is going to be practicing how to use compound interest. So let's go ahead and take a look here. So in this case, you were approved for a bank loan for $5,500. Okay, the interest rate is 6.25%, and it is compounded monthly. All right, so you're gonna get hit with interest every month. Okay, how much is interest will be collected if you decided to pay off the entire thing in 5 years? So in this case, your time is 5 years, and your it's compounded 12 times, right? Because it's every month, right? So first off, we have to, in this case, we need to solve for a future value before we can solve for our interest. So let's go ahead and practice this formula here. Okay, so it's going to be equal. What's your P?
5,500.
Good. We're going to do the asterisk, okay, or the star. We're going to go ahead and open the first parentheses, and the first thing we will need to do is you need to do 1 plus, and then do another open parentheses. What's my R?
0.625.
Correct. And then you're going to do the slash for division, and you're going to divide it by the number of times compounded. In this case, what number is that?
12.
12. Then you're going to close your parentheses twice. Now, Excel will tell you, right? They'll highlight it for you in red, and they'll highlight it for you in black, and then whatever colors that comes after that. But just make sure that you know yourself that when you do that, that you need to have 2 on that side, all right? Then you're going to go for the caret. Your caret should be Control Shift number 6. All right. Then we're going to do another parentheses. All right. Next is going to be my N. What's my N? What's the number times compounded?
12.
Uh-huh. And you're going to calculate it by the time, which is, in this case, it's 5 years. And then you're going to close your parentheses, right? Excel will not accept it if you do not close that parentheses. Okay. Once you have that formula, press enter, and what did you guys get? If you're doing Excel with me. Okay, well, what's the future value?
75,1151.
Yes, it's supposed to be 75,1151. So in this case, what is my interest going to be?
2011-51.
Yes. So imagine this. Out of the 5 years you do not make a payment, or you do make your payment right every month, you're accruing, or you are actually paying $2,011.51 towards interest. So think about it. That's almost half what you originally began with, right? If you began with $5,000 and you got hit with another $2,000 of interest, and you can see how banks make their money because they're letting you borrow money. There's the catch here. The interest is is actually going to be what they're making the money most off of. So in reality, what's going to happen is if you do take a potential bank loan, it's going to automatically calculate this, and every time you make a payment, you're paying off the interest first. You never ever pay the principal unless you make multiple payments. Then they say, okay, you paid for your monthly interest, so now the rest is going to actually go towards your actual original investment. So make sure that you guys know that it is a little trick that a lot of people don't actually know this. So for if you do plan on taking out a loan for any reason, just know that You will be hit with you will be calculated interest, and the minute you start paying your payments, you're only paying the interest off first. Okay, that's how they get you. All right. Question 4. So we're going to continue again, and this time we're applying the same concepts here. Just make sure, because we're dealing with different times, you also have to apply that concept as well. So again, this is the same scenario as before, except with we have a new little feature here where we have the number times compounded. All right. So let's go ahead and do the very first one. If your original principal is 15,000, your interest here is 5.12%, and you're compounded quarterly, so 4 times a year, and you are able to, and you're gonna pay it off, I guess, in 5 years. So let's go ahead and calculate the future value here. So again, it's going to be equal your principal times parentheses 1 plus parentheses again your rate divided by number times compounded, close parentheses, caret, which is your control shift 6, and then you're going to do your open parentheses one more time to calculate your n times your years, which is 5. All right, or your time. So whoever's following along with me, what's my future value? What's my future value?
19,344.84.
Let's see. Yes, good. 19,344.84. All right, and what does that make my interest going to? What's my interest going to be?
43, 44,
84.
4,344.84. Okay, so that's a lot of interest. Okay, a lot of interest. Okay, for 5 years, that's almost $1,000, roughly, a little less than $1,000 a year. Okay, I don't know why I can't change that to black. Okay, sure. You want to be that way? All right. Now, same thing here, except this time we're dealing with 90 days. As we've solved from before, 90 days, right, is equivalent to 3 months, right? Which is equivalent to a quarter of the year. So make sure that you place in a quarter instead for time. All right. So let's go ahead and solve for this right here. Okay. So what is going to be my future value here?
I have 4737.87. I'm not sure it's right.
We'll double confirm that in a second. So you said 4, 5, 4, 9, 11, or what did you say?
I said 47, so I make mistake.
Okay.
47, yeah,
All right.
37.
Okay, so go ahead and double check to make sure that your numbers are correct in the correct places. Dan, did you get the same number as me?
Yes.
Perfect. Okay. All right. So Irina, go ahead and try that again. All right. So then what is going to be my interest?
$27.61.
$27.61. Right? Okay. So let's go ahead and try the last one together since we know 6 months, right, is equivalent to 0.5, right? It's half a year. Okay, so let's go ahead and punch this in again. So principal asterisk, so multiply by 1 plus open parentheses your rate divided by your n. All right, close parentheses twice. You're going to have your caret, open parentheses, your n times your new time because it's in terms of months right now. So we need to make sure that we put it in terms of years. So what is my future value going to be?
I got 399,378,16.
399,378,16. And then lastly, what's your interest on top of that? Or how much interest did you actually accrue?
15,252.94.
15, let me
252.94.
expand my window here. 15,252.94. Yes. Good job. All right. So that's a lot of interest in 6 months, half a year, and you already accrued a lot of interest. So again, this is interest rate is super extremely high. But then again, you are if this is a loan, you borrowed $384,000. So you can only imagine, right? This is a house loan. Well, I mean, the interest rate wouldn't be that high, but example wise. So you've accrued in 6 months pretty much $15,000, right? So I'm going to go ahead and show you this example here. So what this example is, I'm pretty much what it is I'm going to show you what happens, and this is kind of a real life scenario of what happens when you take a loan out and you're making your monthly payments and how much it's actually calculating in. Because with the assumption that this is a real life kind of scenario, this is actually how you apply it. So for this example here, so this is pretty much going to be me showing you. So in this case, for number 5, it tells me that I need to journalize the bank loan from the example number 3. So example number 3, so let's go ahead and take a look at question number 3. So I had a bank loan, right? I was approved for a bank loan for $5,500, right? So here, let's go ahead and journalize that as the first thing. So in this case, let's see what day I had it. So I'm assuming it was on June. So I don't really know what the date is unless, let me see. Let me go back to question number 3. Did I say specific date?
No.
No. So in this case, I'm just gonna go ahead and assume that it's some random date in June. Okay, so June. All right. How do I journalize that I received a bank loan?
Guess we'd let debit checking.
Yes, because the assumption is that when you get a bank loan, you're receiving cash right up front. So it's going to go straight to your checking account. Okay, so checking is going to be the first thing. And then the second thing is, what are you going to recognize here?
Payable.
Not a payable,
Receivable.
not a receivable. We're not dealing with a customer.
Yeah, loan.
It's a loan, right? You can have the word payable, but we already know loans is a straight liability. Okay. Now, question to you: are we gonna also accrue interest? I mean, are we going to also journalize interest?
Yes,
Why?
it's included on the transaction.
Okay. Anybody else want to agree with him?
I don't know. Would we include the interest because it's been? Well, no, I don't know.
Okay. All right. Anyways, trick question there. Usually, the minute you receive your bank loan, no, you don't accrue interest until the following month later, right? So the assumption
Right, if you pay
is
it off immediately, you don't owe any interest. You know, the future accrued interest.
absolutely, but you don't take a loan and pay it off the next day.
Right.
So this is assumption that what the day that you receive the loan, you don't accrue interest that day. You accrue it the day after. Okay, so here in this specific example here, I got it in June. So the first thing is that if it's a monthly compound interest, which we'll talk about, which it does say here, that your automatic assumption is once you get the day that you receive the loan, you don't accrue interest until the day after. Okay, so in this case, I'm taking the straight um, five 5,500. Sorry. There you go. All right. I'm going to change this because I want it to be formatted in terms of dollars. Actually, dollars. No, let's do common style. So there you go. $5,500. All right. So then let's go ahead and read on to the scenario here. Since this is a bank loan, right? You are making monthly payments to this bank loan, okay? And again, when you have monthly payments, it's going to be based on whatever amount that you want to pay. So it's going to be variable. It's not going to be a straight number all the way unless you choose to plan that way, right? And again, it's due every first of the month, all right? And there are no hidden fees and 0% APR. So there's none of those. So no hidden fees or 0 APR. So meaning you're going to get hit with the interest in the following month right after, okay? And bank loans are effective immediately, okay? So again, that means you're going to accrue interest the minute you, at the day after you received it, right? So in this case, because in the scenario for question number 3, we have the scenario that you have the bank loan, right? The interest rate is 6.25% and that it's compounded every month. Okay? So now that we have that information, and again, we're assuming that we're going to take 5 years to pay it off. Okay? So let's go ahead and apply that concept and then place it into here. So on June, right, you didn't make any payments in June because that's the day that you received the loan, right? In reality, you don't pay within the same month as you receiving this loan because obviously you're going to take that money and you're going to go and you're going to spend it. So the principal here is going to be what your original investment was for, okay? Now again, we need to calculate the future value on this. So what we know from here is that our original investment is going to be for the $5,500, and we know that the interest rate was 1 plus 0.0625, and we know that it's going to be compounded every month. So there you go, divided by 12. Close your parentheses, and then we know that the compound is 12 months, and we're assuming we have a goal. We're gonna try to pay it off in 5 years, or that's what the loan was for. They give you 5 years to pay it off. Okay, 5 years. So that means again, my interest or my future value is going to be now $7,511.51, which we solved in the previous section here. Now, of course, how this works is how much interest are you actually accrued if that's what you signed up for, right? And we've already talked about it. It's going to be $2,011.51 for the whole entire 5 years. Now, of course, we're doing monthly payments, and this is how they calculate it, right? If what is going to be the monthly interest? So we know that it's going to be the 2011 51, but we know how many months do we have to pay for this entire thing. So this is, Dan, this is where you said it's going to be 5 times however monthly payments we have. So if we have a total of 12 per year, 12 times 5 gives you 60 months that you have to pay, right? So then now I'm dividing my total interest amongst the entire amount that I have, or entire number of payments I have to pay off this loan. So in this case, it's 60 because it's 12 payments times 5 years gives you 60. So I should get a total of $33.53 as my monthly interest that I have to pay for sure. So in this case, oftentimes if you get that minimum payment, your minimum payment probably is here going to be $35. Because again, we talk, as we mentioned it before, every time you make the minimum payment, you're only paying the interest off. If you make more than the minimum payment, then a portion of it is going to actually go towards your actual principal. So in this case, I need to ensure that if I do make a payment, I want to actually pay towards my principal, I need to make a payment higher than $33.53. So here my current balance is, it's going to be my original principal plus the monthly interest, right? So in this case, it's in parentheses, so I have to subtract it. So that means when I get my statement in the mail, right, it's going to say that my new current balance is going to be for $5,533.51. So this is how the banks, they do it for you. All right, and all you get to do is, as a person who's paying it, that's all you see. You only see the interest. You see that it's been calculated already. It doesn't give you a breakdown of how they charged you. It just says, well, this is your new current balance. This is what you do. Make a payment. So this is how they do it. They calculate the interest based on the entire what your agreement is. They find out how much interest you're supposed to accrue, and they divide it amongst the monthly payments that you have according to what you signed up for. So once they do that, then every month, right, they're going to accrue, it will give you this statement. Now, also with compound interest, you also need to know that if you don't make that payment, you're going to be hit with the interest based on the new current balance. So instead of getting charged the same for the original $550,000, you're going to be hit with the interest on the new current balance. So you're going to get charged the interest based on the 5533.51 instead of this. So that's how you get hit with double and triple interest. And that's how the banks don't tell you, and that's how they make their money. They triple interest, and you get charged interest on top of your interest. So there's a little fun fact for you to know. Next time you open up a credit card, think twice about it. All right, so now that I've received my bill in the mail, as again in my scenario here, I make my payments every single first of the month. So in this case, I'm actually going to make a $200 payment. This is my current balance as of right now. So let's go ahead and journalize this. So how we actually accrue our interest, or how we actually pay, is that, again, so since we figured out how much interest is actually going to be paid towards it, right? That means my mere $200 is going to pay for $33.53 of interest, and it's going to pay the remaining amount towards your actual principal. So let's go ahead and journalize this. So again, as I mentioned before, it's July 1st. And because I'm making a payment to my loan, I'm decreasing my loans. So I'm not essentially, I'm essentially trying to decrease my loan. But another thing I have to do is I'm also paying on top of the interest. So here you will have what's called interest expense. Okay, familiar word, right? Interest expense. You're not going to owe the interest because you're paying it right then and there. And then lastly, for whatever amount that you're paying your amount for, so in this case, let's say I paid using my checking account, then that's going to be for the amount that you actually paid towards. So here, my checking is here. I know that for a fact I made a payment for $200, right? But how much was my interest for that month?
$33.53.
$33.53. $33.53. So how much of my $200 is actually going to pay towards the interest?
166.47.
166.47, and this is where they get you. Okay, this is what I was keep talking to you guys about. When you always make your payment, you're always paying the interest first. All right, and you're only, so you think that your mere $200 is going to cover up, going to reduce your principal. It only reduced it by $166.47. So therefore, of course, because I made the payment, right, it's going to take my current balance, right, and it's going to subtract the $200. So now your new current balance is now at $5,333.53. Okay, because I took my new balance that included the interest and I paid my $200. So I paid my portion to the interest and I've also paid my portion to the principal. So same thing's going to be rinse and repeat here. You're going to recalculate it because now you have a new principal. So again, it's going to be this principal times 1 plus the rate, which is still 6.25%, divided by 12, parentheses, up 1, n, which is 12 times 5, and here you go. My new interest is now 7,284.15. And of course, if I calculate that right, I subtract my future value based on my current balance. My new interest now that is collected is going to be $19.50. So again, every time you make a payment and you try to pay off as much as you can, the only thing, like I said earlier, is that it's already planned ahead of time. When they charge you the interest, it's already solid that you're still going to pay them $2,000 at the end of the 5 months, 5 years. Okay, even if you end up paying earlier, you're still going to still end up paying a huge chunk. And of course, if you're trying to pay it off as soon as possible, then you pay less interest. Yes, that is true. Okay, so here, this is what I'm going to also do too. Now, here's the same concept that you have to also know too, is that even though you made your first payment, you're still subject to those 60 months because that's what you agreed to. So that's not going to change. That's not going to be 59, 58, 57. It's not going to change based on that. It's still going to be the solid number of what you agreed to for the number of payments. So in this case, it's still going to be 60 months. So therefore, my interest here is now decreased by $32.51. So therefore, I'm going to have to add that to make my new current balance to be reflected as $5,366.04. So this includes the $32 interest. All right. So notice this too. If you do make a payment and you make it a lot higher than your minimum, the minimum payment, what happens is that your minimum payment gets reduced. So therefore, your interest gets reduced. So little handy fact here: never pay the minimum. Always pay a little more. Okay. So here, now that I saw that this is my new current balance, now it's August. I received this statement and I decided, you know what? I'm going to pay $250. So let's go ahead and journalize that. So on August 1st, I am now making a new payment of $250. So again, with this idea here, we're making a payment to the loan, but we also have to make a payment to the interest because that's just how it is. Okay. I know for a fact I made a payment for $250. All right. So let's go ahead and calculate how much interest I'm actually paying versus how much is actually going to my principal. So tell me, what was my monthly interest here?
$32.51.
$32.51. So $32.51. So how much is actually going towards my actual principal?
217.
217. So now I'm actually, I'm actually paying a good decent amount towards my actual principal. So again, now that I made my $250 payment, same thing's going to happen now. My new current balance is going to be this minus my $250 payment. So now my new current balance or my new principal is going to be for the 511604. And of course, same thing you're going to do here. You're going to apply the same formula except your principal has changed. So in this case, I'm going to go ahead and fast forward towards this. So in this case, my new interest or my new future value is now 69.87. And of course, I'm going to subtract that out to get me a grand total of interest to be paid to be 18. And then, of course, divided by the 60. That means your monthly payment is now $31.18. Okay, same thing here. We're going to calculate that as part of our new current balance. So therefore, you're going to get a bill stating that you owe $5,147.22, which includes the $31.18 of interest. So then when September rolls around, we decided to pay $300. So again, I'm going to pay $300 this time. So September 1st. Again, same thing. You're going to journalize it the same exact way. Okay. And this time we're making a $300 payment. Okay. And then how much was my monthly interest for September?
$31.18.
$31.18. So $31.18. So how much is actually going towards my principal?
268.82.
$268.82. All right. And of course, I'm going to come here so I can calculate my new current balance. So it's going to be this, right, which includes my interest. Subtract the $300. You're going to apply that formula again. Nothing has changed here except for your principal. And now I'm at $6,619 with a total interest for the remaining of the year to be $1,772. And again, my monthly payments are still going to stay the same. So it's going to be now $29 of interest I have to pay for that month. And of course, that means my new statement's going to be reflecting that I owe now $4,876.77. So this is how they calculate interest for you. So fun fact, but also something that you want to learn as well. So that's how it happens. All right, any questions? All right. All right. So if there isn't any other extra questions tomorrow, will be chapter 10.3. So we will be looking